So number 5, the cumulative frequency diagram below shows information about the distance, d kilometers, that each of 120 students walks to school on a particular day. So a nice smooth curve. How many students walk at most 1 kilometer for the day? Right, so we have to use the graph. Let's see if I could copy the graph. So from the graph, you can see that the distance 1 kilometer is here. So come up, it intersects the curve, it's been red. And then across, so you see to the frequency curve line. So to the frequency side, right? That is there. Now the scale, every 2 centimeters is 20 students, meaning that each individual square will be considered one. Two. So we found 20, 22, 24, 26, 28, 30, which is correct, right? 32, 34, 36. So that'll be 36 students. So for part A, we have 36 students. Who walk at most 1 kilometer, which incorporates this part of the graph here, right? You don't need to shade it here. Using the cumulative frequency diagram, determine an estimate for the median. Now, we have 120 students, which is n, and half of n will be the middle value. Right, so on the graph again, come across to where half of n would be, which is 60 students. And 60 is on this line here. So now we'll draw a dotted line. For some reason, this is not allowing me to draw on the entire. We'll draw a dotted line. On the graph, and then come down. So we are Q2 or a median. And in the scale, every 2 centimeters is 0.5. So 1.2 2.3 to 1.3 kilometers. So the median value for walking is 1.3 kilometers. Now, part 2, they want the lower quartile. The lower quartile, Q1, is 1/4 of the cumulative frequency over a curve at 1/4 of the cumulative frequency. Which is the 15th student. So you comment on the graph where 15 should be, right? So, sorry, not 15. This has to be 120, not 16. 30th students. So you comment on the graph where 30 should be, which is here. And you draw in the graph line, the dotted line, then you meet the curve, and then come down and read it off on the graph. Now, again, every two of these little squares is a 0.1. So it will be 0.1 less than 1, which is 0.9. So 0.9. So Q1 is 0.9. Kilometers. Part 3, they want the interquartile range. In order to get the interquartile range, we have to find what the upper quartile is. And the upper quartile is 3/4 of the cumulative frequency. So that will be 3/4 by 120, which occurred in 90th person, which is here. So again, come across to the curve, come down, and this is in between, so be with the scale Q3 would be 1.55, because every two is a 0.1 would be half of a 0.1, so we 1.55 kilometers, right? So this would have been at your Q2 value, this would have been at your Q1 value, and Q2, the median is in red. Now, not done there. So the question asks for the interquartile range. Interquartile range is Q3 minus Q1, right? This is 1.55 subtract 0.9. If you can't do it regularly, you could use a calculator, right? So 1.55 subtract 9.65, 0.65 kilometers. Now, the interquartile range represents the spread, right? This usually represents between the Q1 and Q3 values, represents 50% of the students in a normal case, right? So in a normal case, 50% of the students would walk within a range of 0.65 kilometers of each other. And that's what the spread or the interquartile range means. And part C, the student is chosen at random. What is the probability that the student walk from more than 1.5 kilometers? So we have to see how many students walk for more than 1.5 or walked from 0.5, 1.5. So on the graph, will come up the 1.5 kilometer mark, trying to be as neat here as possible. The minute falls on this line, which is 80. It's a part C. So 80 students, if you check the bottom part of it, right, walked less than 1.5, right? And the top part of it, or the right-hand part of it, is whoever walked more, right? So in other words, we have to take the total amount of students, the total amount of students, 120, and subtract the 80 students. This will give us 40 students who walked more than 1.5 kilometers, right? Now the probability of a student walking more than 1.5 kilometers would be 40 over the total amount, which is 1/3, sorry. Or if you're using a calculator, you'll get 0.33. Now, either one of these will be correct. I would prefer it in a fraction form, but this will be correct as well. So the same question, part D. We have complete the table below and use the information to calculate an estimate of the mean distance walked by the students on that day. So let me copy this. Now we just have to fill it in, and you can see a trend here. The middle value of the distances walked, right? 0.25, 0.75, 0.125, right? So this will be 1.75, no big set of maths involved. And if you're not seeing the trend, what you do is you take the first and the second, you add it to 1.5, add 2.0, and then divide it by 2. Right? And that's how we get that here. Sometimes you just have to spot the trend to save time. The number of students. Now we'll have to use the graph, I believe, to fill this in. X, number of students, F. Five. So going back to the graph, right? You have to pay attention because we want to fill in these values here. Now, if 46 students was at the 1.25 line, right? I represent there, right? Now, we want to find out at the 1.75, which is here on the graph coming up, right? Then we have to come across here. So 106. Now we have to add common down. So this will be 12. 12 plus 24 is 36. This is like the cumulative frequency, right? Add 46, 12, 82. Now on the graph, we see and that is 106. So the 106 minus 82, right? 106 minus 82, right? So this will be 24 students that got a midpoint of this, right? If I add again 82 plus this, 6, 10. Right? Now again, we're using the graph, the 2.25 line coming all the way up. It's 2 marks less, so the here, which is 1, 6, to 116, subtract 106, just 10. So 10 students, right? Now, to finish the rest of the graph, the rest of the table, if you pay attention, you realize 2.5 is an x, and this is a frequency. 0.25 by 12 is 3. 0.75 by 24 is 18. 1.25 by 46 is 57.5. So you have to multiply the values that we just got. So 1.75 multiplied by 24. This is 42. 2.25 by 10, let's do the calculator for that to know the decimal place 1 point. So we finished fill out the table, but that's not the end of the question. Complete the table to calculate the estimate mean. Now the mean for average is equal to the sum of the fx values over the total number of students. Now that means we have to add this, right? So add 3, add 18, add 57.5, add 42, add 22.5, add 5.5 equal 145.5. The total number of students was 120. So we're going to divide by 120 to give us an average 1.2 kilometers. So the average student walked 1.2 kilometers from the deep. Now, honestly, I've never seen questions like this where you have to read that graph before. It's kind of different. It hardly ever come like this, but still, you have to know what to do. So let me re-explain it again. This table is more or less what you would use to get the cumulative frequency table. Now, cumulative frequency table, right? You would add the frequency coming down. So the short cumulative frequency, first start to be 12, you add coming down, this will be 36, and then 36 add 46, 82, add 24, 106, add 10, add 2. Okay, something wrong with the maths. Because it's a figure 120 at the end. You get 118. So something might be wrong with this here, but it all depends on your graph. Now, I'd probably zoom this in better and get better values. So for 175, going up this line, So 100, 102, 104, 106, so 106. Minus 82 is 24. Right, so this one correct. It should be next one. 5. This is 110, 112, 114, 116. So my maths might actually 36, 6, 7, 12. Strange. But reading from the graph, these values are supposed to be correct. But when you sum it, you subtract 120. Something probably wrong with the numbers that they give us, I guess. So number 6, a track meet. At a track meet, a cylindrical container fitted with a pipe, as shown in the diagram below, is used to serve water to athletes. The cylindrical container radius 12 centimeters, height 20 centimeters, completely filled with water, and the pipe fitted at the bottom dispenses water into the cone-shaped cups. The cone-shaped cups have a radius of 3 centimeters and a height of 8 centimeters. Calculate the volume of water in a container in liters. Now, they give you the conversion 1000 centimeters cubed is equal to 1 liter. So you could continue to work in centimeters and after convert it to liters by dividing by 1000. Write your answer to this cases. So part A, right, volume of a cylinder is area of the circle, which is pi by radius squared by the height. Right, so this is the base specifier to use to reach. It didn't specify what value I should use for pi. So in this case, watching the question, you can see that 12 is not exactly divisible by 7. So pi could be either 22 over 7 or 3.142. So a question like this, where you see the radius is 12 and not a value that divisible by 7, use 3.142. It will make your life easier because you just use a calculator. So 12 squared by the height, which is 20. So 3.142. 12 squared is 144. 20. 9,048. 6. And we want to divide by 1,000. Because this would have been in centimeters cubed. We want to get it into liters. So we get 9.05. They say 2 decimal places. It was going to be 9.486, 2 decimal places. This is more than 5, so you add 134. 9.05 meters. Two water flows from the cylinder container along with the pipe into the cone-shaped cups at a rate of 7.8 milliliters per second. Calculate the time to fill one empty cone-shaped cup. Give your answer. Now, in order to do this, you have to calculate the volume of the cup first, right? So the volume of the cup. And as a cone-shaped cup, but they give you the formula here. It is 1/3 the area of a circle, so pi r squared by the height. So 1/3 by, again, let's say 3.142 by the radius is 3 centimeters and the height is 8. So 3 squared by 8. Okay, do this in the calculator. Step. So 1/3 is 0.333 recurrent by 3.142 by 3 squared is 9 by 8 to 75.33. Now this is centimeters cubed. Again, we want to divide by 1,000 to make it into liters. Right? So the decimal place will move 3 spaces, so you get 0.075 liters. Right? Now, a milliliter is 1,000, or you could just leave it like this. All right. So, if you multiply by 1,000 to get it to milliliters, you get the same answer. So cm cube is the same as milliliters in this case. Right? Calculate the time it will take to fill. So in other words, if it drops 0.75 milliliters per second, all you have to do is divide this by 0.78. So the time would be 75.33 divided by 7.8 to give us so it's 9.6 seconds. So it'll take 9.6 seconds to fill the cup. And give it to the nearest second. So that's 10 seconds. Part C, determining number of empty cone-shaped cups that can be completely filled from this electrical container. All right. So that's where it gets a little bit tricky. This is in centimeters cubed, and this is in centimeters. So what they're asking us to do is find out how many cups we could get out of this amount. So we have $9,008.96 divided by 75.33. And that will tell us exactly how many cups we could get from the entire container. 9,048.96 divided by 75.33, which is equal to 120.12. Now we have to round it off to a whole value, which is 120 cups. So we get 120 cups of water from the container. And that's the end of question 6. A sequence of figures is made from lines of unit lengths and dots. The lines form a series of octagons and squares. The dots are placed at each vertex. The vertex is the point, right? The first 3 figures in the sequence are shown below. Figure 3 of the sequence is shown by itself below. Add more lines to the units, length, and dots to figure 3 to correctly represent figure 4. So let me just observe what it is. So the first one is just a regular octagon. Then you have 2 octagons and 2 squares. And then we have 3 octagons and 4 squares. So the squares went up, right? So in this one, you'll expect to have 6 squares and 4 octagons. Right? So let me try to draw it. It'd be best to draw it, but try something. Right. So we have a dot there to draw a line. Draw a line. Should be drawing another column. And when you're given customer just to try your best to draw it the same size. So this, you know, this way, this way, this way. Right, so this should be the 4th diagram. So that's part A. Part B now, the number of dots D and the number of unit lines that form the perimeter of the shape P form a pattern. The value for D and P for the first 3 figures are written in the table below. Study the pattern of the numbers in each row and table to complete the rows 1, 2, and 3. So 1, 2, and 3. Right? They want us to fill in the table. Now, for the 4th one, you could simply just check easy and add it up, right? So for the 3rd diagram that was in black, there will be 24. So we look on the red dots, 25, 26, 27, 28, 29, 30, 31, 32. Right? So we'll have 32. The perimeter figure, right? We have 20 as the lines. Right? And now if you check it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26. Now perimeter is not the lines inside, the lines on the outside. It's just for future reference. All right, so we finish part 1. In order to do part 2, we actually have to do part 3 first. Right? Now, for this column, we continue to increase by 8 each one. So for the first number, let's call n, the first number n, right? N by 8 or 1 by 8. 8. Now if n is 2, 2 by 8 is 16. If n is 3, 3 by 8 is 24. So this formula or function would be 8n or n by 8, right? Now, in the perimeter figure, we add 6, add 6, add 6. Now, in the first one, it didn't actually add 6. So, we have to create a formula that we would not have to add 6 to the first one in order to get it, because the function that you have to create has to apply for all. So that first one will have to be 0 by 6, right? So in order to get 0 by 6 from 1, we say 1 take away 1, or in this case n take away 1 by 6, and then we have to get 8, so we add it. So in other words, you just say n minus 1 by 6, and then we add an 8. That will be this function. right? Now, and that's the case, in order to work out part 2, use this function and see that this was equal to 86. Carry the 8 across, do some subtract. And we have 6 n minus 1. I'm going to solve for the value of n to get this value here. So this will be 78. You know that this is a multiply from between the 6 on the bracket. So the opposite of multiply is to divide. So divide both sides. So 6 and 6 will cancel out. We'll have n minus 1 is 13. Carry the 1 across, we'll add 1 on both sides. 14. So this will be the 14th figure, right? And 14 by 8, because the function is this here, 14 by 8. Choose 11, so this will be 112, right? And that's how we do that question. So sometimes in a question like this, you have to go forward and then come back, because it wouldn't be able to be adding these going all the way up to 14. You wouldn't have space on your booklet to draw it out. So part C for the question. For any figure where n is greater than 1, the number of dots t is greater than the perimeter. Determine the value of n for a figure in which the difference between d and p is 36. Right? Now, what does that mean? Difference between d and p. Difference, let me just scroll up a little bit there so I see which one is which. Difference between d and p is 36. Now, if you watch d is greater than p for the majority of the table, so you say d minus p is 36. Now, the function for d is 8n. And the function, I should have been a bracket as well. The function for p is 6n minus 1 plus 8 equal to 36. Now, distributive law, right? We will consider this to be a negative 1 and multiply by each term in the bracket to remove the bracket here. This 8n have nothing to remove, so you get 8n. Negative 1 by 6 is negative 6. N minus 1. Negative 1 by positive, it is negative 8 equal to 36. And we're going to do this here. Again, distribute the bracket. And at the same time, move the negative 8 across. So we'll have 8n. Negative 6 by n is negative 6n. Negative 6 by negative 1 is positive 6. Equal to 36. Add 8. And we could reduce this here to get 2n plus 6 is 44, sorry. Again, remove the 6. So 2n is equal to 44 minus 6. 38 divided by 2. Divided by 2. 19. So in other words, at the 19th figure, you'll get a difference between 36. So this will be part C.